everybody to part 2 of the smartphone investigation webinar series. I'm going to go ahead and turn it over to Amber Schroeder, our presenter, and we'll go ahead and get started with part 2. Thank you guys for all coming today. Ready? Just give Amber a second to kick her microphone and camera back on. There she be.
I have slightly better lighting this week. I'm having lighting problems because of all the poor weather. So hang on, let's hit the share. Oh, hang on. All right, you guys should be able to see slides. If not, Megan better say something. So this is part 2 of our 3-part series. So this week, we're going to be talking about analyzing data from smartphones. And it gets started out by, of course, saying, hi, it's me, Amber. You guys saw me last week. If you didn't see last week, I know when we're done with the 3-part series, you'll get access to all the recordings of all 3 parts. So you'll be able to go back and review information if you want, rewatch it. I know last week we missed Kevin sharing kind of some of that live cloud capture information. So we appended it onto last week's recording so you can still see that kind of information. And we'll see if we have to do the same on this week. We don't know. We're running free on this. We'll see. So let's start out with, of course, again, that statistic that says you analyzing smartphones is absolutely the right thing to do. We have so much information that is now existing on these particular devices, and you kind of look at where they're going from: smartphones, mobile phones, tablets, etc. But realize that not only do we have these devices, but we're also going to have integration of other devices. So you kind of see that in this graphic, which I liked very much because it talks about connected TVs, smart home devices, gaming. All of these are your different pieces of digital evidence. And a lot of times our smartphone ends up being that integrating hub. The value of that integrating hub is we're going to be able to pull a lot of miscellaneous different information from it. So we talked last week. We have a physical device, we have cloud storage, and we have compliance data. So I'm sticking with this same theme throughout all 3 parts of this series, but I'm switching it over for analytics. So now we have our standard system data, we have app data, and we still have compliance data because that's already been collected together. And we get some comparisons that we can do in between app data and compliance data because they're going to represent similar data sources. So I might have Facebook app data and I might have similar associated with the compliance data. And I can kind of see that difference of what I collected from the device itself or from the cloud collection versus what I would collect out of that compliance information. So let's start out with our standard system data. So I will say this phrase probably a gazillion times in this, but it's called a reasonable expectation of data. And I think this is where we end up having a lot of problems as investigators is as we use different tools or provided different images from different parties in our investigation, the problem we have is we don't know what our reasonable expectation of data should be. As long as you have that information, that's really going to say, hey, did I get everything I should have from the opposing side in my investigation? Did my tool operate and collect enough of the information that I have at least what is that reasonable expectation of data? So some of that information might include our SMS or MMS information, our contacts, calendar, call logs, notebooks, all of these things, internet browsers, different media pieces associated with it. This is kind of our default reasonable expectation of data. So if I'm not seeing a good collection of this information, there's typically something wrong in that last step we talked about, which was our acquisition stage of the process. So I'd want to go back and say, hey, why am I not seeing a large collection of SMS or MMS? Because let's be serious, it's extremely rare that someone only calls on their phone. Even as people are aging and getting older and older, my grandmother still could text me and she was in her 90s. So we know we should see this type of data. Now, we take this kind of system level data, our default apps on our device, so to speak. We really kind of take it for granted. It goes through a lot of shifts and changes, and our last firmware releases we had in the fall of 2024 represented a lot of those. And so we had to change what our reasonable expectation of data was. So our types of messaging services did a big shift late last year. And why it did this is it was really trying to design a texting environment that was friendly for both Android and iOS and had the same feel and functionality associated with it. So, of course, we've always had our SMS, which is our short messaging service where it's only textual data. We're used to seeing that type of information. Then, as time evolved with our phones, they got better cameras. It's really what happened. We ended up with MMS, which is a multimedia messaging service. So, we'll get textual and media information. So, we have two representation of two artifacts with that one. Then last fall, we really saw the implementation of both Android and iOS into RCS messaging, which is a rich communication service. This allows you to do textual and media data, but that extra step further that it goes with it is really what makes the two kind of blend between it. It allows you to see when someone is typing a message, which typically when you went from two opposing sides, so our iPhones and our Android users, that was not something that could bridge that gap. You wouldn't see our typing bubbles, our dots that people are so excited about seeing. RCS messaging has changed that. So now we can see it between two different platforms, both between Apple and Android. So that's big. It also adds improved metadata for us in forensics because we're going to get things like read receipts associated with our messaging with it. That's great. We like that because it means that our suspect has interacted with our messaging service. So we like getting more metadata. That's always a win for us. We also now get emoji responses with this. So immediately we can have, instead of on my Android, because I'm an Android user, whenever an iPhone user would heart a message, I would get a text that says, they have hearted your message. Now I can actually see the interaction directly with the message, so I know what type of emoji metadata might have been added to that message. So that infers some type of an emotional response with our messaging surface. And the last one is that it requires a Wi-Fi communication to be able to function within the RCS environment. Because it's pushing out more data, it's changed the way that it's actually transmitting it. And what will happen is the device will then default back into an SMS message when it doesn't have that Wi-Fi communication available to it, or it prompts the user and says, your message can't be sent because this person is offline right now. Would you like to change the way it's transmitting? And they can change from doing it as an RCS transmission over into an SMS transmission. So I know it's kind of one of those you're like, really, this couldn't be that important, but it's huge because, again, you get cross-platform changes. So both iOS 18 and Android 15 and 14 actually went retroactively with Android, now allow this type of process to go through. And these are just some good examples for you of how it would look on an iPhone versus an Android and how this has changed some of our metadata that we have an expectation with our analytics. Now, what do you have to do for your tool choices? So what really needs to happen is that your tool has to go through and really tell you that you're seeing an RCS message versus an SMS or an MMS message, because it is technically a new messaging type. So you should see that in your analytics like you do here, where it's saying, hey, this was an RCS sent message as opposed to one or the other. That immediately tells me that I can then also typically find the Wi-Fi location associated with this RCS message. So it's leading me down my investigative path with something as simple as messaging. I know the little things we take for granted, right?
Hey, Amber, we have
Yeah.
a question that
Yeah,
came.
go ahead.
Can RCS be hidden or erased later? I know certain apps can do it, such as Snap.
RCS messages is going back to your original messaging system. So it's not like Snap where I can go through and say, hey, I'm going to have this message only exists for X amount of time. Telegram does that. There's a couple others that do that. It's still something native within the actual file system itself. So it's something native to the devices. It's not considered a third-party app. So it's not going to function the way those third-party apps would. It's a setting change, believe it or not. It's just a setting change that gives us more forensic data. So we like that kind of setting change. Okay. So let's talk the other setting changes. And again, these are the things that you might not have noticed, but you've got to see those shifts happen in your tools. This is why I told you you've got to track what happens with firmware releases and what happens with releases with your forensic tools. And all of my screenshots are done with Paraben's E3 tool. But if you are not a Paraben user, it's one of those that you can look in your other tools and see it, but you need to make sure it's there. So call history actually made a big change, and it changed with iOS. So iOS now started tracking what is actually making the call when it is done, which is an interesting thing. So those arguments that people say, they said, wait a second, I did not call someone, meaning they didn't do a telephony call, they did a Wi-Fi call. And as you guys know from using your own smart devices, that you'll see those shifts and changes happen within what you want to do with it. Those are impactful to you because, of course, if I do Wi-Fi calling, then I should be able to also see what Wi-Fi connection I was with it. I might have additional geolocation data, and they'll continue to lead you through those different forensic fingerprints. So look for that important metadata on some of the default information that you get when you process through a device. I think we really take it for granted, and we just kind of are like, oh, I have, 100,000 text messages, no big deal. But each one of those text messages and the metadata they can have, or the call history metadata that it can have, can be impactful to your investigation. So let's look at some of this data. So when we look at data and it's associated with our smartphones, there are really two different ways to look at it. And anyone who's heard me ever give any type of presentation, this is my best analogy I have. I've kept it for years because I like it so much. It really clicks for my brain. But really, we look at it as parsed or unparsed data. So parsed data is those neatly lined up chairs. And each one of those chairs could represent a different data source. So one line of those could be all the SMS messages. Another one might be the MMS messages. And then another one might be the RCS messages, or you could look at it the same way that says all those chairs represent my contact address book. And so each chair is a different individual I might know. I know Kevin, I know Megan, I know Ralph, I know all these different people, and they represent a chair in there. And then there's specific metadata about each one of them in those chairs. Now, the other side of it is when we have unparsed data, because data is changing so rapidly, specifically with smartphones, because apps are constantly going through different updates, we can end up with that unparsed data. And it feels and it looks very similar to this pile of chairs here. It can represent different apps. So it might represent a Snapchat app. It might represent Telegram. It might represent RCS messages. And my tool simply wasn't going through and making them parsed and pretty and easy for me to go and do my analytics. So keep that in mind when you're looking at the two pieces of information. It doesn't mean the data isn't there. It simply means that it hasn't been made good looking. It hasn't been parsed out and made easy for you to reference. So you end up having to do a little bit more work. So here's some good example for you. So this is an example in WhatsApp. So this is parsed WhatsApp data. I have the messages, I have the chats that happened. We see I have outgoing, deleted, recipient, media duration, Latin longs, all of the details that I would expect to see with the messaging associated with WhatsApp. My tool has gone through and it has parsed out this information to make it much easier for me to do my investigation, right? Then I have this other data. So this is what ugly unparsed data might look like on a smartphone. It doesn't mean that the tool has done anything wrong. It simply means that there has been a flux in between when they last parsed something and when that data was available, or they never parsed it in the first place. But this example for you shows you that you can still get the same data that you might need out of it, such as this is browser information. So I can see the URLs associated with their browser history with it. And I just have to manually look for that information. This is why most of your forensic tools in their analytic portion go through and have things like full text indexing. So when I search for this information, whether it's parsed or it's unparsed, I'm still going to get hits on that particular data. So what kind of data do we look for with smartphones? We really have three primary types. And when I say that, there's obviously lots of other files in there. But when we're looking for user-oriented data, so that's going to be my potential evidence, we're really looking at SQLite, JSON, and plist files. So they're not the most complex files on the planet, but some of them are a lot easier to go through than others. So I've just got a couple examples for you, just in case you have not personally had an opportunity to look at them in their raw form. A lot of your tools go through and parse that information for you. And so they'll break down your SQLite for you. They give it a viewer, same with JSON, same with plist files. But the best part about it is we're not looking at an encrypted file format with any of these. We're really looking at raw textual data that we get to put together to make sense in our analytic steps. So here's an example for you from an app called Meet Me. It actually is referenced in our file system as My Yearbook. And that happens a lot where our app, as far as its naming convention that it might have in its marketing information, is not going to match up with what we're going to see it when we actually do our acquisition. All that is it has been purchased by another company. TikTok's a good example of that. TikTok is not referenced as TikTok within its acquisition files. It's referenced over as Musical.ly because that was the app that they purchased. Then when I go through and look at that raw information, if my tool isn't parsing out Meet Me into the lovely little rows that I like, I still need to look for the data because this is an investigative area I'm interested in. I can go and look in the SQLite and you see I've gone through, I've looked at the databases and I've opened up the messages, and you can see similar information in those messages. The difference is it's not fully parsed because this is what it looks like in that raw SQLite form, but it's not something that is stopping me from doing my investigation. I can still see all of that valuable information in there. If I go and look into a JSON file, which typically is more development oriented with it, I can still see my particular data I'm looking for as far as my investigation goes. So for example, this one, reasonable expectation of data would be I'm pretty much able to find most of my usernames. They're very rarely encrypted when it comes to my analytics. So I see my username there, I see an ID, I see other information associated with this account that still can help me as I move through. And if I were to go through and index or search this case, I would still get hits in these JSON files. Our last one here is a plist file. And a plist file is what you're going to see a lot more common on our iOS devices because it's a property list file. This is what they prefer to use, where you'll see SQLite kind of a mix between both Android and iOS. I still see my valuable information here where it has my user has logged in once, what they've done with their cache, when was the last time they logged in. All of those details are there for me to find as an investigator. But again, that doesn't mean that my tool is going to be able to parse everything associated with it. One of the important things you find out in doing your analytics with smartphones is that you need to make sure that you're always manually reproducing yourself whatever your tool has and finding out what those differences are. And the big reason is because of apps. So I just had this because I really like the screenshot, but pretty much as you saw with those, if you're reading this, then you can read. Great. If you can read any of that data in my last couple slides, then you can do investigations on any app out in the App Store because you're going to be able to go through and see those similar file types in any of the different apps that are structured out there. Whether it's a game, a messaging app, it doesn't matter. You're going to see similar structure. If you see no data structure like that, and maybe you only see the account information, that's really telling you that the app probably pushes its data up to the cloud. And so you know you have to expand one level deeper into your investigative process. So let's talk about app data. I'm just setting my timer so I can see what time it is. So let's look at apps. So this is the app view that I typically use. When I look at this information, the things that I'm looking for on here is not necessarily the standard apps. And I know a lot of people do their investigations in different ways, but I'm looking for data that is telling me something that might be unique to my particular suspect. So for example, I know for my suspect is into Louis Vuitton. They have a Kindle. Okay, they're definitely an Apple user because I see a lot of Apple apps with it. They have multiple streaming accounts associated with it. All of those are kind of building up what I would call as my suspect profile. If there was something very specific there, so let's say they were looking to do sell Louis Vuitton bags illegally because they were not real ones, they're doing knockoffs, then I would want to know what is happening within that Louis Vuitton app. where normally I wouldn't find that to be a very interesting investigation. But if it was affected by what I was actually looking for, I would want to go and see what might exist in that raw data. But the chance that my forensic tool is going to parse that particular app is like null. There is no reason a forensic tool would normally be parsing that because it's such a specific use case. So keep that in mind, that it's nice to be able to say, okay, here is my full list of apps. Let me find the ones that are potentially unique to what my particular investigative scenario or use case is that I'm working through. And then the nice thing is being able to go and reference those raw data points as well. So what I start with, if I have a unique app, I might want to go and investigate what that app does, because I believe that every digital forensic investigator, oh no, I'm so sorry, there potentially is going to be a lot of barking because I am having a heat repair because I had a ton of snow. That's why it's so bright in here. So the way I start is I go into the App Store and I pull up what the app is actually able to do, because any permissions that an app gets granted within the App Store write-up is typically where I'm going to end up seeing data sources. So I might see that SQLite data or that plist data. So the data shared category and the data collected category are keys if I have to go and manually look through this app information. Then I like to set up a test device, and then I like to actually use the app. Because if I'm one of the people that has been living under a rock and never used TikTok before, since this is my example app I have up because it's just recently gone back in the App Store, then I need to understand what it does in the app so I know potentially where my suspect is generating data. If you've never used an app before, it's very hard to look at that raw information and then put it all together to have it make sense for what you're seeing in the data sources. So like I said, this is the data shared category. This is the data collected category. So I have an example of what I saw on the App Store there. And then I also have an example of what I'm seeing in some of the parsed information I got from my tool. If some of the data that I see there, and again, TikTok just barely went back in the App Store, and I don't see it in my parse data, maybe I want to go and check the manual information as well. There's always a chance that the information that was done by the app was changed, and then my forensic tool hasn't changed and updated to match the same information in the app, because it is always in flux. It's why we want to be able to manually go and review that information as well. So what if your tool didn't see any of that data I was just talking about? That's why you have references back to other raw data sources associated with the app. So I can go and I can look at the raw data source with Mozilla, Outlook, any of those, or TikTok if I was going and looking in that example, and I can see all the different shared sandboxes with this particular app. Because once an app goes through and grants access to those areas, we're going to see different data spread occur between the two different apps. And a very good example for you is when you start looking at it in the context between Android and iOS. So this is app permissions in Android and how it's shown in the tool. So as you look here, we can see things like, I'm trying to pick one here. We'll just go Android Auto at the top there, make it easy. So we'll see all of the different metadata permissions that have occurred. We see a 0 if it doesn't have access. We see a 1 if it does have access. As soon as it has access between those two different areas, that's when potentially we can see data from our suspect occur within our acquisition. So we might see that information when we go and review those apps manually. It is always one of those things that when you see the permission levels that are granted, that's why I always start there and really understanding it. That's when I want to make sure my tool is doing enough for me, or if it is missing something, that I'm manually doing the extra steps on top of it. Again, our forensic tools typically release by quarter. Apps release probably every 4 to 6 weeks. So there's multiple releases of an app that can occur in between. And so you've got to be prepared to be able to manually produce that data yourself. If I were to look at the same information, oh, sorry, this is just a larger one of Android, so you can kind of see it further out to see all of those. But I have it as well for iOS because it is a different feel between the two different devices. So this is when we see information that is extra force. It's one of the things I like about Apple. It's why I'm not an Apple user as well, as I don't care for all the extra information it chooses to store. But it's whether or not we see things like location service, whether it was denied or it was allowed. Was it allowed by the user? Was it allowed by the system? And you kind of you'll put those pieces together to make sure you understand what data you should be seeing within it. Because if location services is allowed, I should have some geolocation information associated with that app. So I would manually want to go and review that information. Geolocation is one of the harder pieces of data to parse out of a mobile acquisition because it's really just a string of numbers and it doesn't have that set pattern to it like a social security number or a credit card number does, so that you can use a grep expression for it. So that's one of the reasons it's one of the more difficult pieces to do. So if you are looking for that information, check your app permissions and then look for those location services being activated. Other examples for you on whether or not the policy was set by the system or it was set by a service policy or a user consent with it. That also tells me a lot about what my suspect is potentially doing, because in this example here, you can see that the user does agree to tracking with GasBuddy. They allowed authentication for it through their keychain data, and the user had consented to it and the date that they last consented to it as well. So we get a lot of extra good information from the metadata with our apps. So what kind of data do you see with your apps typically? So this is kind of my reasonable expectation of data when it comes to apps. We see my username. You'll typically find the email they use to sign up with the account. If they use something like their Google credentials, their Facebook credentials, any of those to be able to add into another app, I'll typically see that as well within the metadata associated with that app. You potentially will see the passwords to be able to log into that app as well. They're mostly, all of this information is kept in plain text. If it has any communications associated with it, I'm going to see those databases. Those are typically located in SQLite data. So I'm going to be able to see that messaging traffic, just like I had in my example with MeetMe. And then you might also see specific feature data. One of the important things you have with feature data, again, if you've never run the app, you're not going to understand what that feature data might be potentially with it. That's why you have those test devices that you run your different apps on to say, oh, I understand this is what happens in TikTok. Oh, I understand this is what happens in GasBuddy. Whatever it may be, I always make sure on my test devices, I have both an Android and an iOS device, so I can make sure it matches up to the feel of what my suspect was using as well. Here's a good example for you of that. So I'm going to see my reasonable expectation of data. This is obviously a browser, so that makes sense to me. I see a browser history, a cache, but then where my forensic tool kicks in and does that little bit of extra is when you see that recovered information associated with it. That's when it takes some of the unique technology that you get from our industry to be able to recover those entries that were marked for potential deletion or removal. And we just reference those as recoverable when it comes to smartphone forensics. Remember, your smartphone keyboard doesn't have a delete key, so we typically call it recoverable data. The exact same thing if we were going and looking within an app manually. So this is an app that was not parsed by my forensic tool. This is the GoodRx app. So it's a prescription management app. It was relevant to my investigation. So I go through, I look for the information. I then find the primary preferences, again, my reasonable expectation of data. And then if I go and look within that plist file, as you can see, I'm going to see that they use their Facebook credentials to create their GoodRx account information. So that tells me I potentially can go to a secondary data source and find that information associated with my suspect, because it might be stored within their Facebook data or within their compliance data. It was like I had a segue. So here, let's see their compliance data or look at that information. And this is my third favorite data source, besides obviously working with the device itself or getting access into the cloud. The compliance data information, it might actually be my favorite data source because it represents a holistic representation of everything my suspect has done. So if I get access to this, I'm a happy camper. So again, our compliance data, we would add that as an additional piece of evidence. So we're not going to acquire that from our other sources. This does require consent in order for you to collect this information. Once I have that information, I can then bring it into my tool. And here is an important part. So this is a screenshot from within TikTok. So this is a very good example for you. Remember that each app store will tell you if there is potential compliance data associated with their individual app. It's typically located in the security practices section, and it shows that you can request the data to be deleted. That's really how it's kind of tagged out in there. Now, if an app is storing it enough that you can request it to be deleted, it means you can also request a copy of it. And that's an important aspect. For those of you who are within the public sector environment, it also means that you're going to have a better response to your subpoena because of it. They are collecting all of it. Typically, they're doing it for statistical information, your use data, all of those things that make it so they can market and advertise to you appropriately. So keep that in mind. So this was my example I showed in the last session, just in case some of you missed that first session. I'm so sorry. My dogs are being loud today, and I didn't even have them that close to me. It is National Love Your Pet Day. I love my pets every day, but today it's National Pet Day. So I have my account. We saw my different areas that I could potentially collect from. And then now I have my request back. So it took 48 hours for Facebook to do my request. When I pull that request into my analytic tool, so this one I'm using E3 to do my analysis, I pull that compliance data in and you can see the different pieces. I only pulled in my Facebook and Instagram just to make it easier for you. And we're going to break down some of that data. Now, this is my data, so I know what I should be seeing there. And I recommend that all of you, as an exercise, go and request your compliance data as well, because it's the most data you're familiar with. But we see some valuable artifacts that are existing just within my compliance data here. So here is my Facebook information, and we have the information of who I followed. So that is telling me a lot of how I'm interacting within my social media environment. And of course, who I'm following can be very impactful to you. So I follow things like the 2 Husketeers. I'm sure you heard my Huskies talking in the background just a minute ago. The Butter Dish. I live in the South, so that totally makes sense. There's a restaurant that's all focused on butter, but different things like that. This is telling me when I started following. It also has another entry that tells you when I stopped following them. That could be impactful for an investigation. You might also see information such as the address activity. And when I say the address activity, it is actually tracking within your compliance data, which you don't get out of the app data when you acquire the phone locally or when you acquire it from the cloud, is you get all the IP address information associated with the activities and interactions on this social media platform. Typically, most social media platforms carry this information. Why wouldn't we want the IP address? Of course we would, right? And the last one, of course, our account recovery status. So this is an interesting one. I'm sure many of you know I do a lot of different stalking cases. I do a lot of them pro bono. And one of these reasons I like this particular data is it tells me if someone else is trying to gain access into their account. So this can be important for me in the context of my case, but I can't get this information from the app from a direct acquisition or from a cloud acquisition. I have to get it from that compliance data source. It's one of the reasons that's what makes that last part of kind of that 360-degree perspective on our smartphone forensics. Let's take a quick look at that Instagram data as an example. Oh, I went too far. Hang on. Our last known location is associated with this. So this is associated with me accessing my Instagram at a specific location to do the mindless scroll or to do a post, whatever it may be. But this one is nice because it gives you actual GPS coordinates for it. So I can then map that. I told you how important that geolocation information is. And I do not get this when I process the app natively or from the cloud. This is data that is reserved within the app and it can't be pulled. And it does not matter if I change my acquisition process on this particular app. None of the acquisition processes affect this data that I'm seeing in the app. The next one, of course, is I can then pull, of course, that account information I told you is valuable in there. Anything from phone numbers, usernames, all of those details that are in there, date of birth, all of that is something that I can pull very directly out of my compliance archive. So our last little section here, and I'm going to pull up a couple slides, and I have a co-presenter here, Ralph Gregal is in here, and he's going to demonstrate some of this because we're really seeing a future change to how we're doing our digital forensics analytics. And I know you guys have had AI shoved down your throats in every presentation you probably ever attended, and yes, we're going to do that again, but we're going to do it in the context and perspective of digital forensics. It's not just AI that can write a post for you or something that can rewrite a great summary to a report, because they can do those kind of things. But this is really an investigative aid, because one of the things that we have within our lab environment when we do consulting work is we do a peer review. And when we do a peer review, it's all about that buddy system. So this is our buddy system. We're just doing it digitally. So I never close out a case without having another person look at it to make sure I just didn't miss something, or maybe they're more familiar with something than I am. My tool does a lot for me, but we still need our humans behind the keyboard, behind the mouse, to make sure that they're really telling our engines, our tools, our manufacturing capabilities, not manufacturing, our analytic capabilities, sorry, to really get in there and say, this is the data I'm looking for. So part of that is that Parabon is releasing this into April. It's called Xandra AI, and Xandra means to help, because that's really what we're looking for. Our data has grown so exponentially, it's actually exhausting to go through 500,000 text messages. It is problematic. That's a lot of data, and it's a long history of our suspect. And remember, I call everyone a suspect. So Ralph, are you in and unmuted? Because I am sharing screen.
I am unmuted.
Okay. All right. I'm going to let you explain this. I've got the two different kind of architectural sides of Xandra, and then I'll switch and you can share the screen and show it running.
Okay. So the way that Xandra works is you'll be able to export the data natively from E3 to the formats that it will be able to ingest and work with. There are 3 different deployment options. Number 1 is that everything resides on the cloud. So all the processing, all the data, all that can just be up on a cloud, and you have the ability to process everything that way. So the way that the architecture runs is the input and the output is always through a large language model. And then it uses a mixture of agents approach, a mixture of experts as well. So depending upon what the data that needs to be analyzed is, if part of it is mathematical, it will go to a mathematical model. There's a cross-correlation engine that links documents together. And there's also a model for analytical capabilities of Windows networking systems, et cetera. So for example, if part of your data involves firewall logs and VPN logs, as well as forensic data from a server or from a desktop, it can link that the attacker came in here on the firewall, was given an internal IP address here. That internal IP address then went to this server over here, ran this particular SQL query, and here's where it was dumped to the local machine, and here's where it was emailed out. So it does that whole cross-correlation thing. So the processing can happen on the cloud. The second and third options are where you're running everything on a local system, and Parabon would provide all that, the systems for that. So in that context, all of the data resides locally on your investigative system, but you can choose whether the processing, the real heavy lifting, happens on a cloud, and we have a lot of cloud GPUs that are crunching all the numbers, or whether the local GPU and the NPU on that system will do all the number crunching. So if you're using the cloud-based processing, then you'll see things progress a whole lot faster. If you're doing it all locally, then it'll take a lot longer for it to process through, right? But that's the same basic architecture. But the input and the output is always through an LLM.
Yeah. So I'm just changing out so Ralph can share his screen instead of me sharing the screens, because you just got obviously the workflow associated with it, but he can go through and actually show you how he would use it. Ralph's also a digital forensic investigator, has been for a very long time. I don't remember how long we've known each other at this point. So long time.
1995.
Yeah. There we go. So go ahead and share yours.
Okay.
I'm going to mute.
You see it?
Yep, you're good.
Okay, great. All right, so this is some data that we have put up. So here is a bunch of Facebook data that was received from the Fairman software, right? So the process is you have to export the data out. You then have got to import it into the AI, create folders that become data, and then the AI then parses through that data source, right? So I'm going to go here to the knowledge. I'm going to go over here to yours, and I'm going to connect to the Facebook data, right? So what you see here is just all the data that was removed or were exported out from the Paragon tool, right? In the CSV data, we've got a bunch of timeline activities, all CSVs, and have things like calendar items, messaging, etc. So I'm going to go back over here, and I'm going to go over here. I'm going to go over to, actually, I want Eva, right? So let's take Eva's email and Skype messages. So once the data is in the vector database, what you have to do is you have to tell the AI you now have access to this. So typically my first prompt is, you now have access to this data source. Use this data source, nothing else. And then in this case, list any that contain emails of all that data, all the CSV files that were in that folder. Just list the ones that contain message data. The AI then goes through, analyzes all those CSV, and then says, there's a couple of CSVs that have got message data. So messages.csv contains iMessage and SMS communications between these people over here. The Lee Roger one is a bunch of Viber messages, and that's her father. It kind of gives you that information about what is in that data. And then you can link back to the original set and be able to review it if you want to, right? So if I wanted to do, let's say, a follow-up message, how about provide a narrative of the conversations Eva is having in file, which one's this called? Messages.csv. Okay, in .csv. Now back through, it will analyze all that data and provide a list of the information. So instead of you having to sit there and review message after message after message after message, the AI look at it and provide a narrative of what this data is all about, right? But it can also parse different types of data sets. So for example, this is a bunch of network logs, fall logs, application server logs, as well as data taken from memory scraping. So this is a point of sale system that was analyzed. Live memory was captured. So we have a memory dump. We then look at it, dump all that data out, feed it into the AI, and simply just give it a command of analyze and cross-correlate all the activity and all these logs for anyone who's trying to access, copy data, get into other systems, etc. And so it'll analyze all that and then give you an analysis that says, based on the analysis provided, what you have here is you have an external connection between one server and another server, and then there's lateral movement within the network. Finally, malware is deployed onto the point of sale system. A process, which is now given process ID number 4572, called scraper, is initiated, and what it's doing is it's scraping through memory and looking for the pattern of credit card numbers. It then tries to exfiltrate the data using multiple SSH connections, and the Wireshark security logs, all the network trafficking, analyzes all that. So it brings together all that disparate pieces of data from various sources, and then just analyzes it, and then presents it to you in a holistic kind of approach.
It's really, the idea is that it's the perfect helper for you, because obviously data is growing exponentially. It's harder and harder for us to be able to comprehend anything, all of it, without help. So Ralph, we've got a couple questions in here because we're going to get to the end.
Sure.
So I'm going to just say them and then we can both answer accordingly. So this one is more for you, which is, what are the data security privacy controls for the Xandra AI platform? Is any of the customer inputted data available to anyone else to view, or is it all kept used in train models?
So all of the data is stored on an encrypted cloud drive or locally. If you're going to the encrypted cloud drive, then the security mechanism that's being employed is called Lydian, which is a company based in Canada, where we can change out the encryption algorithms and all that pretty much every minute if we wanted to. So if that model is deployed, the individual user will get their own private instance of the app. So everything stays in encrypted folders that only the user has access to, using a multi-factor authentication mechanism. The one we've chosen is QR code. So what happens is, as part of the registration process, you have to link your mobile device to the account as well as to the browser, so that only that browser on that computer or the systems that are associated with that user account can access the data, and then only the mobile device associated with that user and those browsers can access the data as well, right? If it is a local installation where it's running all on a PC, then all the data is still encrypted in the Lydian encrypted drive, but we don't have the requirement for a 2FA to be able to get into to get online, right?
So our next Xandra question, because the questions change up here. So
I'm sorry, and none of the data is shared with other models for training or stuff like that.
Nope, it remains private. So one of those is, has Xandra AI been tested in court proceedings? The answer is it's brand new, so no.
Correct.
And does Xandra hash and verify imported data? That's already happened in the pre-prep process with E3 going through and processing the information. And then the prompts logged and time-stamped. I don't know, do you want to pull up one of the outputs, Ralph? I know you had a couple of them prepared.
The output of the...
I think we did like the Facebook output and the compliance data output.
Here's the Facebook data. So in this case, we had all the Facebook data that was brought in, which contained 57 HTML files And then the prompt is simply to cross-correlate the files and provide a detailed narrative report of what all that Facebook data indicates, and then identify the user and the device specifics of that. And so what it did was go through and analyze all the Facebook data, all of the connected users, login activity, what kind of device it's loaded on, browser specifications. And then the further prompt was to search across all the messages and provide narrative of each conversation, and then search across all the posts and provide a complete narrative of including posts, replies, et cetera, et cetera. And it went back through, identified that, you know, the messages are with these people over here. There are both posts and interactions, and kind of just takes the entirety of the Facebook interactions and puts them all together for you.
And then it has a separate report that it outputs as well. So then one of the nice things is that this is your helper. So you can go back and reference back to your original evidence. You can do a secondary report from there, and it kind of all comes together. So it's kind of a combination in that one.
Yeah, it's a helper. It's not designed to do the case for you.
No.
It's designed just to show you holistically how everything's kind of tied together. So then you can go back and manually check for yourself, because obviously, if you're going to testify about this in court, you need to be able to testify in first party that I did this, et cetera, et cetera.
And that's why you see different data points referenced that says, oh, okay, I need to go and look at the communication maybe between Eva and Valerie as an example within your summary. So that's why you can go back and take a look there. It really is a helper. So some of our other questions real quick, we have, do videos sent via MMS or RCS, because SMS doesn't have videos with it? Do they compress differently? They do the natural compression associated with whatever the limitation associated with the firmware. So if it's iOS or if it's Android, it will compress accordingly. So you will get some quality differences when you're sending any type of video via text. I don't understand that next question, so I'm going to have someone either explain. We'll go back to it. Okay, so this is an interesting one. Can you speak more on why you use Android versus Apple? You've heard that Apple is more privacy driven. I have also seen the Apple commercials saying that they are more privacy driven. I just don't always believe them. I use Android simply because I feel I can have more control over what my device is doing than what I can with Apple. Otherwise, I have to kind of relinquish my control over to Apple. So that's my opinion. Ralph, do you have an opinion on that one?
You know, I don't use Apple because everything you do on that Apple device is logged, recorded. They can tell you that they are security driven, but trust me, they're not.
Yeah. I don't think either of us believe them.
No.
Yeah.
Especially the new one with the whole AI built into it.
Oh.
That's a huge spying machine right there.
Oh, I agree. Those are just our opinions. So there we go. I don't know the app name you are using. I'd need you to explain that more. I think I have it out of context.
I think that one is the that one came up when you were showing Parabin screenshots, I believe.
Oh, okay. Yeah, I'm using Parabin's E3 platform for all of my different screenshots in there. Obviously, I'm the CEO of that company. It's my primary tool. So that makes sense. But that is what I am using to do most of my analytics. I do use other tools, but they have to go through my test paradigm before I decide to use them in an investigation. And you guys saw that in the last webinar where we talked about ranking your different tools. Other questions, like what are your thoughts about learning about mobile penetration testing? Would you recommend? Very long association. You guys can see that in the chart, in the chat. So we do some app penetration testing, but I think with doing pen testing, you really have to also have somewhat of a coding background. That might all change depending on what happens in the future of AI. It is changing daily. But for right now, I would focus into those areas, really look at understanding your structured databases associated with apps, and then really get some good reverse engineering skills in there as well. That's really what's going to help you. I think a forensic investigation is kind of your starting point to doing an app pen test. When we evaluate them we always look at them from a forensics perspective first, and then we look at them on how they actually are interacting with different users. That's kind of a more complex question answer there. Good question. So, Ralph, they want to know if Xandra can translate from one language to another.
Sure.
Mm-hmm.
151 different languages.
Yep. And can it, I'm guessing this is Xandra from Bob, can it ingest SQLite data directly?
No.
No. It does have to go through some structural changes for the AI to not get confused by the data. So that's part of why we'll have an output in E3 where you can take that more complex data into a simpler form to give it over to the AI.
Yeah, probably in CSV format.
Yeah. And information on Xandra, we have the base information associated with that it's coming up on the website. We're actually having a larger launch associated with it at PFIC on April 3rd with our planned spring release that it's kind of incorporated in that. You'll see Ralph again. We'll have more information available on it because the whole goal is Xandra in ancient Greek actually means the helper. So the idea is that you're going to get an extra helper, and it kind of matches up. When was the new NVIDIA machine? Wasn't that April as well? I think it was.
Yeah, April or May, something like that.
It was something like that. It's in the spring.
The supercomputer?
Yeah, the supercomputer. Yeah. So it matches up so that if you wanted to keep things locally, you'll actually see some of that hardware evolution that was announced at the Consumer Electronics Show in January start coming out about the same time. So you might have some lab adjustments that you might want to make. Okay. And the last question that's in there still in the Q&A, I just don't know. I need more context for that question. But if there are no other questions, anyone? Pop back over there. No other questions. All right, awesome. Well, if you do have any other questions, we will see you next week for our final session that really is talking about the presentation of data from a smartphone. I've got some other colleagues that are coming in that are going to talk about it, especially from some of the legal standpoint, since everyone knows I am not a lawyer and I do not play a lawyer on TV. So I want to make sure that they give you some proper options for it. So it's next Thursday at 2 p.m. Eastern, and Megan and Cyber Social Hub will be sending you out reminders. So thank you all for coming.